Hello and welcome to Make It Easy series of webinars from Spyrosoft. Today's topic is effective QA framework development. My name is Jadranko Kovačec and I'm a senior QA automation quality engineer in Spyrosoft Solutions here in Croatia. More about me you can find on my LinkedIn profile. So let's get started. Effective QA framework development, what it is. Let's imagine that project started and you have task to create a robust QA test framework. That means that you need to take some steps. What would be the first step taken? With whom will you communicate? How to start with that task? We will cover all those questions in this webinar. So let's see today's agenda. Effective QA framework development is composed from understanding the SDLC and SDLC. Then QA role phases, essential data for the QA framework, and quality management. Test plan, QA templates, writing test cases, setting QA test repository, using the API, test automation, CI/CD test pipeline, and best practice tips. Understanding the SDLC and STLC, what's the difference? Before we go much deeper into the subject, software development lifecycle focus on application. Then STLC or software testing lifecycle focus on testing the application that is being developed. Software lifecycle in general is related to planning of activities, what comes when and when comes what, environments in terms of cyclic development process, ticketing system management to understand the flow of a ticket. So when you open a ticket in some system that manages those tickets, then that ticket has its life cycle from, let's say, opening until the closure. Then effective communication among the team members, stakeholders, clients, etc. So this is basically the difference in overview, plain overview. More deeply to that, in software development lifecycle, we have planning, analysis, design, implementation, testing, deployment, and maintenance. In software testing lifecycle, we have requirements analysis, test planning, test design, test environment setup, test execution, defect reporting, and retesting and regression testing when the devs complete their work, and test closure, which ends with having test reports and overall quality overview. So now that we understand the basics of SDLC, then we have some QA role phases. Imagine yourself as a QA specialist going through a journey of creating whole new testing infrastructure from the beginning to the end. This is something that I derived and created from my experience on one project. I divided this thing in 4 phases. First phase is get yourself operational. Second, analyze the needed work. Third, start producing QA work. And fourth, future directions and maintenance mode. So let's see the phase 1. Phase 1, get yourself operational. That means that you need to connect with people, to understand who is who. This is for better collaboration. Another thing is that you need to have credentials to do your work, to do something that needed to be done. For that, you have credentials, and credentials are very important and necessary for the tasks. Third thing is in here that methodology alignment must be understood and aligned. That means that you need to understand the methodology you are working on. you need to comprehend the ways much deeper that we are going to explain right now. Application familiarity means that you need to know your application well. So learn what developers, devs, etc. are working on. And work environment setup, that means that you need to set up your working environment so you could do the work needed to be done. In phase 2, we have analyze the needed work. This means that you need to define or identify testing environments. Depends if those environments already exist or you need to define them. Selector or POMS usage, that means that when you are testing web applications, you need to have certain buttons, etc. managed. So you need to encourage your developers to use the selectors for those. Then documentation review, you need to study project documentation. Testing scope means that you need to define with the client or stakeholders what you will test and what you will not test. Then you need to choose tools for the work. You need to have some access to database if that project is using databases. Also, when you select tool for testing, then you need to have approved that testing tool. That usually is done from the client or stakeholders side, because some testing tools could be, let's say, very expensive for use. So you don't want your client to have something bad said to you. So let's move on to phase 3. Start producing QA work. You need to gather use cases and use scenarios. Comprehensive manual test case creation. Once you gather use cases and use scenarios, then you create manual test cases, which is obvious, right? Then after this, once you have manual tests, you start creating automation test cases. You use manual test cases to see which ones could be automated. Once you have automation test cases created, then you continue to CI/CD test pipeline setup. In one time period that best suits you or the needs of the project, you have requirements traceability matrix if needed, right? So we will say a few words later about RTM. Sixth place in phase 3 is document templates. We will also say something about bug reports, system downtime, etc. later in our presentation. And at the end of phase 3, we have QA testing framework documentation. That means that the whole situation, the whole QA framework needs to have some documentations prepared. So to explain how it is working, how it will be maintained, etc. About maintenance and other stuff, let's see in phase 4, future directions and maintenance mode. Number 1, framework development direction. Collaborate with stakeholders. Number 2, enhancements, how to improve QA test framework. And number 3, maintenance planning, what to do when development is finished. Number 1, you need to collaborate with the stakeholders, with the people that are paying for the project. You need to see where they want your QA framework development to go, in which direction. Then enhancements means that you need in every iteration possible, every new thing that you introduce to QA framework, you need to do certain enhancements to the way of work. And the third thing, maintenance planning, means that what you will do when this is at the end, when the developers stop their work, and then you go to maintenance. So that is phase 4, and we are finished with explaining about the whole process of QA specialist. Do we have any questions, maybe? If we have, you can freely write them, and we will see at the chat at the end, and to choose the best, maybe, questions, and we will answer it at the end. Let's move on to essential data for the QA framework. You familiarized yourself with the application that's behind us, but you figure out what it has, that it has some login mechanisms in place, and what are they? Okay, and then what is required for those mechanisms? Certainly, it is required grant type, client ID, client secret, scope, username, password, tenant ID, scope, app URL. You need those variables, data, etc., to successfully mimic the login process. Then we have other prerequisites, if they are available. QA testing account email, Swagger URL if that exists, URLs for app environments, ticketing system URL like Jira, like Azure DevOps, etc. Information about responsible teams, so you know to whom to address tickets. Then bug reporting procedures. If already those procedures exist, then you need to align with those. Then URL to the CI/CD pipeline, URL to the cloud solutions such as Microsoft Azure, Amazon Web Services, and Google Cloud Platform. Let's move on to quality management. This is essential knowledge because it is crucial for the QA framework development. Without quality management, you can't really plan how the QA framework will be developed. Comprehensive planning means that take in consideration as much as possible. Early planning benefits is related to quality management plan. And benefits are identifying quality criteria and setting clear quality expectations. Then focus on risk mitigation. Quality issues addressed early are the cheapest ones. Then ongoing refinement. You're improving your effectiveness every iteration that goes by. Let's move on to actual documentation. And we now can see the test plan, which could be the first document ever that you create. To this slide, you can screenshot, or you can get back later after this presentation is finished if you want this template for yourself. In this test plan, we have introduction, scope and limitations, strategy and testing approach, organization, QA team, resources, success factors, and we could have a lot of different and much more things on those test plans depending on the needs for the project. Speaking of templates, we have some QA templates. Test report, QA task, planned downtime notification, testing request, bug report, and other templates. Depends on the needs of the project, stakeholders, team, etc. Test report is created from project information, executive summary, testing overview, test scope, test strategy, test cases execution summary, defect summary, defect categories, testing environment, test metrics, recommendations, conclusion, and approval. You can also get back to that slide later in the stored video. We have QA task as one of QA templates. QA task is good to have because of transparency of your work, and stakeholders could see what you are doing. In QA task, you usually have title, assigned person, tag, area and iteration, description with overview and acceptance criteria. Another template is planned downtime notification. Why would you need to have that? Stakeholders and teams are aligned and synced on the maintenance part. That means that sometimes you need to bring development, UAT, prod, etc. environments down, so they will not be accessible. Then you have this notification that has subject, purpose, environment, application affected, date and time, expected duration. You can customize it as you want. This is your choice. Then we have testing request, one of QA templates. This is created from ticket title, QA person assigned, testing request, testing data, etc. So you populate it with the needs that you need, right? So why? It saves a lot of time. Lots of stakeholders could ask you to test something, and if you have multiple stakeholders, then you know what is going to be. Let's continue with bug report. Fill the needed data for ticketing system or standalone report. Overview, you need to be verbose in bug reports. Steps, start from login or visiting applications URL. Expected result, what is desired behavior, and actual result bug occurrence. Then you have system info. Why would you have those bug reports? Devs and you will be happy to, let's say, to have test steps that you will get back to them later. Bug report can be opened today and can be closed in 1 month. You will forget what will happen in 1 month. Trust me. Do we have any questions for those templates? Do you might have any solutions better than this? What's your opinion about that? I'm sorry. Let's continue with writing test cases. On this example, we have functional and regression end-to-end testing in this example. And you can see we are using Azure DevOps test plans. You have another tools such as Jira with Zephyr add-on, Azure DevOps services, TestRail, Qtest, Microfocus, ILM, etc. The main structure in writing test cases is like having a test plan as a parent, then for a child is test suite, and for the lowest child item is test case. You need to define the standard for writing test cases, as you want to have all test cases in the same way. Approach that you could use, one of those is step-by-step or procedural approach. This is traditional and most straightforward approach, series of steps and expected results, and you can see that is the simplest way to work with. Do not haste with the writing test cases and be accurate. Another thing is behavior-driven development. Collaborative approach between developers, QA, and non-technical stakeholders. What that means? You have given, when, and then. That is something that differs that case. So this is called Gherkin syntax, and you could use it. I didn't use it because it provided me a lot of trouble when implementing in the project, and it is good to explain something to non-technical persons, and you could try it. Then use case based approach. This is something that test cases are derived from use cases or use stories, and test cases represents what a user might encounter. You choose whatever suits the best for your project. So that was the last one you could see in this presentation. Test coverage. Earlier, we spoke about requirements traceability matrix. So RTM document or matrix is used for test coverage percentage. That means that you have, let's say, some number of requests or requirements. Then you have accommodating number of test cases. List of requirements or functionalities or features are covered by test cases. So we can continue with the questions. Do you have any questions? Do you have some approach that would be better or better writing something? How much earlier should QA work start before dev work? Or dev work should start before QA? What do you think about it? Please let me tell this in the comments, as I'm very interested in the overall information about that. Let's continue with setting QA test repository. Have already set up prerequisites, installations, environment variables, add-on, etc. Used for test automation, versioning CI/CD pipeline, GitLab, GitHub, Bitbucket, Azure repos, etc. And parallel to this, have a folder on your local machine to have allocation to where you will sync data or code from online QA test repository. Let's move on with that, the same tone. In QA repository, you have some, let's say, project tree. It is important where you put which file. Watch for the hierarchy. What you need and what you not need. What will be the scope later down the road? Which tests you will be conducting in future. In project tree, you have also something to do. So let's see the example on your screen. I used gitignore file to reduce unneeded data traffic. And also I used linting as a way to standardize the testing code. With gitignore file, it is excluded reports, videos, screenshots, node modules, etc. That is a heavy burden to freely communicate with Git. Action list that we done for QA test repository is prepare development environment, tool selection, QA test repository setup, local folder setup, installation of testing tool and dependencies, project structure setup, use of gitignore file, syncing changes, testing and maintenance, collaboration and communication, documentation. You can get back to this slide later when it saves. You can provide some questions, or I can answer you. Let's say, how much earlier should QA work start before dev work? Well, that depends on the project and what could be done and what is the scope of the project. It is not good if QA arrives, let's say, for a month after devs start working, because when project kicks off, then you need to have, let's say, some amount of time to prepare environments, to prepare overall knowledge of the project, of the things that you will be developing as a QA. So it is really important to start as early as possible. So another question I could answer is, why are you using Azure over Jira? Pros, cons of Azure over Jira. Well, it didn't depend on me. As I arrived on the project, we already had defined Azure DevOps because the solution was being developed in .NET. So in that tone way, they also had Azure DevOps on the project. So I adopted it, and I don't see the big difference in there. Jira, I also worked before in Jira. It is, let's say, the same thing, but on the other way. Let's continue with the webinar. Using the API Swagger. Consider starting with Swagger, basic tool for API overview, helpful for overview, bad for testing, good to have for setting the Postman tests. Okay, that means that if you have possibility to use Swagger, please use it. It will help you. I use it as the start and moved from it to Postman. This is basic tool for C exposed APIs. This is okay for overview, but it is not very good for testing purposes. For more testing purposes, we have Postman. So this is the basic overview of the Postman test. That you have some request, and you can see on the left side there is test collection. In the middle is test code. Lower section is filled with test results and status, and upper right corner is defined environments. You could step in many pitfalls using the API or Postman or any other tool. Incorrect or expired access token, revoked access or poorly managed testing account, incorrect client credentials, incorrect redirect URI, user denied access, expired authorization code, mismatched authorization code and client ID, restricted scope, invalid refresh token, bad configuration overall, either in your tools or some firewall, proxy, certificate, or else issue. Or like you can barely see on that screen, you tried with bad configuration for too many times. Don't do that. For that, you need to obtain those credentials I mentioned earlier. Grant type, client ID, client secret, scope, redirect URI, username, password, etc. About OAuth 2.0 login mechanism. You can see the mechanism to log in, to mimic the login in Cypress. It is similar to Postman, but a bit different. You use the response and store it in some variable, environment variable, then you can read from it later to log in to the, let's say, some pages of your application. You can see that this is grant type password, and that it is going to send and receive responses, and those responses you can use in further actions. Questions. Few weeks ago, I discovered a bug report tool gem. Think that is coming, that is something cool. It collects all data you can integrate with Slack, Jira. Okay, thank you. Who would you consider responsible for writing test automation cases if the team? If you have both manual and automation QA. Well, that should be defined in the organizational structure. That depends. If you have, let's say, team lead, then that person should take care of who will do what. If you have enough place and space, etc., then the manual tester, if he wants to learn, you can encourage to work. But automation tests are usually done by automation engineers. So I'm not really sure if the work should be strictly, let's say, assigned to one person. Depends on the project, on the structure, on the time, depends on a lot of different things that I don't have enough context in here to answer you the exact question. If you want, you can contact me on LinkedIn or however it suits you best, and we can discuss it a little bit deeper. Let's continue with test automation. Prerequisites for test automation are VS Code or similar tool. QA test repository, manual tests, those are optional, but usually you have them. Before test automation, gitignore file, Cypress or similar tool, local machine folders, linting add-ons, and GitHub Copilot. If you never used GitHub Copilot, please take a look at it, because it is next generation tool that can help you with creating code. So you just put, let's say, comments, what you would like to do, then it suggests you something that it assumes you might want to. In VS Code, you can see marked with number 1, functional testing folder. Then with number 2, you can see smoke testing folder. Then in commands.js, number 3, you can see that as a storage for reusable functions. Then number 4 is elements.js. Remember that we spoke about POMs and selectors for web page UI. This is the place where you define them and store them, because you will not define them only in the test, like the whole title of that element. Then you have cypressconfig.js and package.js. Those are configuration files out of today's scope. And Azure Pipelines YAML. This is configuration YAML file that you can adjust it much into detail in pipeline. So let's continue. We will say something about it later. Code example is shown. This is in Cypress, just an example, where you have login functionality being tested with valid username and password and with invalid username and password. So login functionality goes from login page to credentials to login button, and the results at the end are checked. Running tests in Cypress could be in interactive mode, defined like a script in package.json, and it could run in background as it runs in CI/CD pipeline. You don't see what is going on there. Steps for test automation are: prepare the environment, categorize test cases, use test cases as guidelines, leverage GitHub Copilot if you can, consider code reusability, project structure and configuration, replaceable credentials and selectors, test execution, verify execution results, and iterate and enhance. If you would like to see it more up close, please get back later to this slide. Do we have any questions maybe for this part, or maybe some of your solutions, proposals, something that you would like to share with us? Please feel free to write us. The next thing is CI/CD test pipeline. Move local test automation to CI/CD test pipeline. Address the needs of the project or client. Customize the solution as needed. Everything is said in here. After test automation is created and it works on your local computer, machine, etc., then it is time that you can move it to CI/CD test pipeline. CI/CD test pipeline could have results just beautiful, like you can see on your screen. So the steps for it are: create a new pipeline, configure pipeline settings, define variables, specify agent pool, agent Cypress installation task, add Cypress run task, publish test results. Optional is to add some notifications, save and run the pipeline, and review results. YAML script that we spoke earlier about is, let's say, more into details that specifies which steps, dependencies, conditions, etc. you can do in CI/CD test pipeline. Benefits of having CI/CD test pipelines are: early detection of issues. That is the cheapest way, as I mentioned before. Faster feedback loop, consistent build and deployment process, automated testing, triggers, schedules, etc. Efficient collaboration, reduced time to market, increased confidence in deployments, consistency, rollback capabilities, traceability and auditing, scalability, easy with cloud solution, infrastructure as code, that is automated solution, DevOps culture is supported and encouraged, continuous improvement, feedback for future enhancements, and resource optimization. And we are almost at the end of the presentation. So I would like you to see those best practice tips that I've gathered, let's say, in 1 year of working with development of QA test framework. Store your instructions using OneNote or comparable application. Keep the data and instructions well organized. Keep in mind data security. Do not share given credentials. Do not over-engineer the solution. Often sync with the theme and stakeholders. That is very important, and you need to stick with that. Document test cases clearly. You need to have some standard. In the whole procedure of building QA test framework, you need to have some standards, ways of work. Then automate repetitive tasks. Regularly update test documentation. Perform regression testing. Collaborate with developers. Stay informed about industry trends. Perform exploratory testing. Utilize version control systems. Monitor test execution. Conduct peer reviews. Prioritize testing. Provide detailed bug reports. Continuous learning. That is the thing that is most important, and you need to develop yourself as a specialist. With every iteration, you need to be better than last time, and validate data integrity and enforce standards. So we are at the end of today's webinar. This is time when I will answer your questions, if there are any. If there aren't questions, please feel free to contact me on LinkedIn or on my email that is provided on the screen. Also, please scan that QR code you're seeing on your screen to check out our open positions here in Spirosoft. You might need something, you might find something interesting, etc. Please feel free to see it. Do we have any questions, maybe? Okay, if we don't have any questions, thank you for the participation in this webinar. This water, I'm not really sure what did they put to this water, because it's really bad. So thank you very much for today's time, and see you next time. Bye.